Section number 49 is entitled Line Integrals. Suppose you have this equation, x squared plus y squared equal to 9. Well, that's a circle centered at the origin of radius 3. Let us give it a path. So that's C. Goes along the circle in that direction. Now, we want to find the piecewise smooth parameterization of this path C. Well, if I were, we know that x squared plus y squared is equal to 9. If I were to divide both sides by 9, I get x squared over 9 plus y squared over 9 is 1. But that's the same as x over 3 squared plus y over 3 squared is equal to 1. Well, I would like for that to be cosine theta, because when I square it and I add on, if I let that be sine theta, I square it, I get 1. So like I said, what's inside the brackets, I would like it to be cosine theta. So solving x over 3 equals cosine theta for x, we get x is 3 times cosine theta. And if y over 3 is sine theta, then 3 sine theta, 3 sine theta, it must be y. And it works out. Now if x is 3 cosine theta, then x squared will be 9 cosine square theta. And y squared would be 9 sine square theta. When you add the left-hand sides, you get 1. Excuse me, you get x squared plus y squared. You get x squared plus y squared. And when you add the right-hand side, you can factor out the 9, and you get 9 times cosine square theta plus sine square theta. But what's inside those brackets is 1. And of course, 9 times 1 is 9. So when you add the left sides, you get x squared plus y squared. When you add the right side, you get 9. Exactly what we're supposed to get. So, for the answer, you should say that r of t, t is the parameter, is 3 cosine theta in the I direction plus 3 sine theta in the j direction. But now you do need to make a comment on theta. Theta goes between 0 and 2 pi. It's a complete circle. It's a complete circle. And that's the end of the first problem. We wrote the parameterization of x squared plus y squared equals 9 according to that given path. Now, do another problem. This one's going to be considerably harder, or at least a pain, more of a pain. Suppose the path starts at the origin, it goes 3 to the right, and it goes up 3, and then 3 to the left, and down 3, in that direction. 3, 3, 3, 0, 0. Those are the corner points. Now, how would you describe this? And the answer is piecewise. First, we're going to go from the origin to 3, 0. So y is always 0. Now, how would we describe the x? Well, we can call it TI is going in the I direction. The Y value is 0, if you like, plus 0J, and T goes between 0 and the number 3. That is always on the y-axis because you have 0 J's, and the x is just t, where t goes from 0 to 3. Okay, now we're going up. Y is changing, x is always 3. That is, it's going to be 3i. Now since y is going up a unit of 3, I'm going to say t goes from 3 to 3 more. T goes from 3 to 6. X is always 3. Now, if I say t minus 3j, when t is 3, j is 0. That puts me right here. And then t is 4. 4 minus 3 is 1. That puts me up a little bit higher. And then t is 5. 5 minus 3 is 2. So it's a little higher. And then when t is 6, 6 minus 3 is 3. It puts me way up here. So it is working. Okay, now we're on the top. We're at 3, 3. And we're going to the left. In this case, y is always 3. I know it's 3j plus 3j. Now the x is going from 3 to 0. It's going from x equals to 3 to x equals 0. That's a distance of 3. So t has to start at 6, and it goes 3. It goes to 9. Now, since it's decreasing, when t is 6, you want this to equal 3. When t is 7, you want it to equal 2. You want it to be decreasing. So what you're going to do is say 9 minus t in the I direction. When t is 6, this will be 3. Exactly the point 3, 3. When t is 7, 9 minus 7 is 2. So it's going to be right here, where y is 2 and x is 3. And eventually t will be 9. 9 minus 9 will be 0, which brings us right here. It's working like a charm, which is good. Now, we're coming down. We're going straight down. Along there, y is always 0. So plus an understood 0j. Plus 0j. Now, x is always 0 there. How I knew that is I was just about to say y is going from 3 to 0. Y is not a constant, but the x value is always 0. J, well, it's going from 3 to 0. That's the distance is 3. We start at 9, and we let t go 3 more. 9 plus 3 is 12. And what it's going to be is, it's going to be 12 minus t in the j direction. When t is 9, 12 minus 9 is 3. You'll be at x is 0, y is 3. 0, 3. When t is a little bit more, 10. 12 minus 10 is 2. Be at 0, 2. When t is 11, 12 minus 11 is 1. You'll be at 0, 1. And when finally t is 12, you'll be at 0, 0. Exactly where you should be going. So there it is. There is your answer. That is your parameterization of that path. Okay, so we want to evaluate the line integral over the indicated path. So we want to integrate x minus y ds over the path C, where C is RT is 4ti plus 3tj. And t fluctuates between 0 and 2. Okay, so we should find r prime of t with respect to the x value, the I component. Now, if this is x of t, we just get 4i plus the derivative of that is 3j. The length of r prime of t is going to, of course, be 5. It's going to be 4 squared plus 3 squared, the square root of that. So you should recognize that as 5. You're in Calc 3 already. It's the square root of 25 or 5. 3 squared plus 4 squared equals 5 squared. Somebody says to you 3 squared plus 4 squared, you should say equals 5 squared. So the square roots are equal and it's 5. 3 squared plus 4 squared equals 5 squared. 5 squared plus 6 squared does not equal 7 squared. 12 squared plus 13 squared does not equal 14 squared. But for 3, 4, and 5 it works. So now, go to the top line. And x is 4t. Excuse me, minus y, which is positive 3t, dt. And t goes from 0 to 2. And of course, 4t minus 3t is 1t, or t. And the integral of t dt is t squared over 2 from 0 to 2, which is 2. 2 squared is 4, divided by 2 is 2, minus, you plug in 0, you get 0 squared over 2, which is 0. 2 minus 2 is 2. But we did forget one thing. Sorry. We're supposed to multiply this by the length. The length of r prime, which was 5. Which is 5, which is 5, which is 5, and 5 times 2 is 10. You have to multiply. Forgot about that. And there's the answer. Very straightforward type of problem. Suppose you wanted to integrate x squared plus y squared plus z squared ds over some path. And the path is RT is equal to sine of TI plus cosine of TJ plus 8TK. And T fluctuates between 0 pi over 2. So remember, this is X, this is Y, and that's Z. So X squared would be sine squared T plus Y squared cosine squared T. That's 1. That's 1. Plus Z squared. Z squared is 64T squared. Now we need to find R prime and the lengths of it. R prime of T is, well, the derivative of cosine of, derivative of sine of T is cosine of T. The derivative of cosine of T is negative sine of T. No square. And the derivative of 8T is 8. So the length of R prime of T, well, it's this squared plus that squared. But that's 1. Plus that squared, that's 64. So it's the square root of 65 times the square root of 65 dt. And t goes between 0 and pi halves. Okay, so the square root of 65 I pull out in front. The integral of 1 dt is t plus the integral of 64t squared is 64t cubed over 3 from 0 to pi over 2. Well, when you plug in 0, I hope you see you're going to get 0. So we just need to plug in pi over 2. That gives you pi over 2 plus 64 thirds times pi over 2 cubed. I factor out pi over 2. You get square root of 65 pi over 2. Factored out pi over 2, so you have 1 left. And here you factored out pi over 2, so you just have pi over 2 squared that survived. So you get the square root of 65 pi over 2 times 1 plus 64 pi squared over 3 times 4. The reason I didn't say 12 is because 4 goes into 64 16 times. So we end up with the square root of 65 times pi over 2 times 1 plus 16 thirds. 1 plus 16 thirds is 19 thirds. Think of the 1 as 3 over 3. So you get times 19 thirds, which is 19, let me say the pi first, is 19 times pi times the square root of 65 divided by 3, 2 times 3 or 6. And of course there's a typo there, but somehow I lost the pi over 2, I think. Pi over 3. It was a good try. You get the square root of 65 pi over 2 times not 1 plus 16 thirds, but 16 pi squared over 3. I guess I will get a common denominator. I'll think of the 1 as 3 over 3. So I can factor out the 3 in the bottom, multiply it with the 2, I get 6. Square root of 65 pi times 3 plus 16 pi squared. There's your answer. So suppose you have the integral of x squared plus y squared ds over some path, and that path happens to be along the x-axis from x equals 0 to x equals 3. So in this case, r of t, it would just be ti, where t goes from 0 to 3. So r prime of t would be 1. It would be 1i, and the length of r prime of t would be 1 squared plus the understood 0 squared. However you do it, you get 1. We need to multiply by that 1. Now, x squared, well, x is t. So x squared is t squared plus y squared. Remember, this is ti plus 0j. Y is 0. So, you get y squared dt. Well, that's just t squared. Integral of t squared is t cubed over 3. And t goes from 0 to 3. So you get 3 cubed over 3. When you plug in 0, you get 0. Subtract the exponents. This is just 3 squared, or 9. Okay, very simple problems. Do a few of these and you realize they're not that bad. Okay, suppose you have the integral of x plus 4 square root of y ds and over some path. See, and the path is just the line from 0, 0 to 1, 1. Now, when you're given 2 points of a line, if you're given 2, 3, and say 4, 1, you should look at it. Do you see anything common to both points? In this case, yes. If you add x and y, you get 5. That's the equation of the line. If you have 2, 6, and 5, 15. Oh, if you multiply x's by 3's, you get the y values. If you multiply x by 3, you get, that means equal, the y value. That's the equation of the line. When I look at this line C, I see that x and y are always equal. Y is equal to x. That's exactly what I see. That's exactly what I see. Y and x are the same. You want to find the slope and use the point slope formula? Fine. But x equals y. I know, I can just see that. So now we have to define R of t. R of t, well, it's just going to be ti plus, of course, tj, because x and y must be equal. And t goes between 0 and 1. For example, r of 0 would be 0i plus 0j, which is 0, 0. R of 1 would be 1i plus 1j, which is 1, 1. So it is working. Now, r prime of t is 1i plus 1j. And you should know the length of that vector. It's the square root of 2. And you go over 1 and you go up 1. It's the famous 45-45 degree right triangle. 1, 1, square root of 2. Okay, so what we get is the square root of 2. Now x is t plus 4 times the square root of y, but y is t dt. ds is not dt. ds is square root of 2 times dt. And t goes between 0 and 1. So you get the square root of 2 times integral. Integral of t is t squared over 2 plus the 4. Think of the square root of t as t to the half. That integral is t to the 3 halves divided by 3 over 2. And this is where t goes from 0 to 1. And you can factor out the square root of 2. And when you plug in 1, you get 1 squared, or 1 over 2, plus 8/3 times 1 to the 3 halves is 1. So 8/3 times 1 is still 8/3. So it's a matter of adding this. Let's get 6 on the bottom. Multiply the half by 1. That's 3 over 3. You multiply the 8/3 by 1. That's 2 over 2. And you get 3 over 6 plus 16 over 6, which is 19 over 6 times the square root of 2. Erase this. In the next problem, we want to find the integral of f dot dr over some path t. And you were told that f of xy is the component vector xy, y. And the path is r t is 4ti plus tj. And t goes in between 0 and 1. So this here is x, and plus t is y. The xy is 4t times t. xy is 4t times t, 4t squared. And y is just t. So I have f in terms of t. And I need dr. So r prime of t is 4I plus 1j. That's really dr over dt. Multiplying both sides by dt, dr equals 4I plus 1j dt. And f is equal, so this is the same as 4,1 dt. And f is equal to 4t squared t. So f dot dr, you multiply the x values, or the I values, you get 16t cubed plus 1 times t is t times the constant dt. So that's what f dot dr is. It is 16t cubed plus t dt. And t goes between 0 and 1. Integrating this as a snap, this integral, well, we know t to the 3 becomes t to the 4 over 4. And, okay, so it's 16t to the 4 over 4, and 4 goes into 16 4 times. Plus the integral of t is t squared over 2. So we have 4t to the 4th plus t squared over 2 from 0 to 1. You plug in 1, you get 4 times 1 to the 4th is 4, plus 1 squared is 1 over 2. And when you plug in 0, you get 0. So you get 4.5, or 9 over 2. And of course we have a big error this time, because I don't know how to multiply half the times. Let's go back to FDR. When you multiply this, you should get 4t squared. I mean 16t squared, not 16t cubed. So we want to integrate 16t cubed plus t dt. 16t squared plus t dt. And that becomes 16t cubed over 3 plus t squared over 2 from 0 to 1. So you get 16 thirds plus a half, which is 32 over 6. I multiplied 16 thirds by 2 over 2, which is 1. Allowed to do that. And here I'm multiplying by 3 over 3. So I get 19/6 as an answer. (32 over 6). Plus 3 over 6 is 35 over 6. My final answer, 35 over 6. how do I want to evaluate this integral along the path C? 2x minus y dx plus x plus y dy. It goes as follows. It starts here, it comes down to here, and then it cuts across. The line from 0, 0 to 0, negative 3. This line, and then from 0, negative 3, we want to go, what's a good limit? We want to go to our 2, negative 3. And that's the direction we're going. So we have two paths. We have two paths. C1 is you go from 0, 0 to 0, negative 3. And then for the second path, you go from 0, negative 3, and you go to 2, negative 3. Those are the two paths. Now, for the first path, for C1, you have y goes from 0 to negative 3, and x is constant. X is 0, which means dx is 0. On the second path, y is constant, but x, it goes from 0 to 2. Y is always negative 3, so dy is 0. Okay. So, over the first path, we have x is 0. So x is 0, dx is 0, and y goes from 0 to negative 3. So we get negative y times 0, which is 0. I won't bother writing that. Plus 0 plus y is y dy. And y goes from 0 to negative 3. Okay? Plus what happens on C2. On C2, we know that y is negative 3. So that's negative 3, and that's negative 3, and dy is 0. So we get the integral from of 2x minus 3 times dx, and in this case, x goes from 0 to 2, plus x plus negative 3 times 0, which is just 0. So this is the integral that we need to do. So we get y squared over 2 from 0 to negative 3 plus this integral is x squared minus 3x, and x goes from 0 to 2. Okay, you plug in negative 3, you get negative 3 squared, or 9, over 2. You plug in 0, you get 0. So that first evaluation is 9. Plus, you plug in 2, you get 4 minus 3 times 2 is 6. You plug in 0, you get 0. So we have 9 over 2 plus a negative 2. You have 9 over 2 minus 2. This is 4.5. Take away 2. You have 2.5, or 5.5. Just one moment, please. Okay, it looks like 5/2. It actually completes this section. Good luck with it.